I hope all of you are doing good. Let's start today's chapter, Rational Numbers. Introduction. We have so far studied about the systems of natural numbers, whole numbers, integers and fractions. We may recall them as follows. Natural numbers, the counting numbers 1, 2, 3, 4, etc. are called natural numbers. The set is denoted by n. Whole numbers, the number 0 together with the set of natural numbers is called whole numbers. Often it is denoted by w. Okay. And integers, negatives of all natural numbers together with the set of whole numbers is known as integers. Set of integers is denoted by I. Okay. Fractions, numbers in the form of a by b, where a and b are natural numbers, are called fractions. Thus, these are fractions. They occur at the right side of 0 on the number line. Need for a new number system. Even the set of integers and fractions do not answer all our problems. Further, if we consider an equation 2x plus 3 is equals to 0, it has no solution in the system of integers or fractions. Thus, we shall have to extend our number system in order to find the solution of the above type of equations. The new system that we shall be introduced is the system of rational numbers. We shall study in detail about rational number system in this chapter, rational numbers. In this number system corresponding to every positive fraction to the right of 0, there is a corresponding negative fraction to the left of 0. Thus, minus 1 by 5 corresponds to 1 by 5. Minus 7 by 8 corresponds to 7 by 8 and so on. Rational number, a number of the form of p by q, where p and q are integers and q is not equals to 0 is called a rational number. Okay, examples, all these are rational numbers. Fractions as rational numbers. A fraction, say 2 by 3, is in the form of p by q, where p and q are positive integers and q is not equals to 0. Hence, every fraction is a rational number. Next, integers as rational number. Consider the integers 6, minus 6, 7, minus and so on. We can write 6 as 6 by 1 and minus 6 as minus 6 by 1. Similarly, we can write 7 as 7 by 1 and minus 7 as minus 7 by 1. Thus, we can write all integers as a by b, where b is equals to 1. Hence, all integers are rational numbers. 0, okay, 0 is also a rational number. Remember that, okay. We know that 0 is equals to 0 by 1 is equals to 0 by 2, or you can write 0 by 1 by 2. Okay, so what? So we can write 0 in the form of pq, where p by q, where p is equals to 0 and q is any number other than 0, right? Thus, we notice that all natural numbers, whole numbers, integers and fractions are part of the rational number system. Okay. Standard form of rational number. A rational number p by q is said to be in standard form if q is positive and the integers p and q have no common divisor other than 1. In order to express a given rational number into standard form, we first convert it into a rational number whose denominator is positive. Then we divide the numerator as well as the denominator by the greatest common divisor. Okay, example, express each of the following numbers in the standard form. Minus 32 by 40. Okay, so the denominator of this rational number is already positive and the greatest common divisor of 32 and 40 is what? 8. 8 4s are 32, 8 5s are 5. So, minus 4 by 5, okay, is the standard form of minus 32 by 10, right? Next, equivalent rational numbers. Consider the fractions 1 by 3, 2 by 6, 3 by 9, 4 by 12. We know that they represent the same fractions. They are called equivalent fractions. Equivalent fractions are obtained by multiplying the numerator and the denominator by the same factor. Also, we observe that p by q and r by s are equivalent fraction. Then, if p by q and r by s are equivalent fraction, then p into s is equals to r into q, okay, about which you have already studied in the previous class. So, 1 by 3 is equals to 2 by 6. So, if we cross multiply them, that is 1 into 6 is equals to 2 into 3, that is 6 is equals to 6, right? Positive and negative rational numbers. We know that every integer other than 0 is either a positive integer or a negative integer. The same is true for a rational number. Consider the rational numbers 3 by 4 and minus 5 by minus 7. Both the numerators and denominators of these numbers have same sign. Okay, means positive and negative, both signs are equal, same. Such rational numbers are called positive rational numbers. Okay, see, these are the examples of all positive rational numbers. Now consider the rational number minus 2 by 5. The numerator of this rational number is minus 2, which is negative, and denominator of this rational number is 5, which is positive. Such rational number is called a negative rational number. For example, all these are negative rational numbers. Okay, hence the rational number whose numerator and denominator both are positive or negative is called positive rational number, and rational number whose either numerator or denominator is negative is called negative rational number. Okay, exercise 2.1, write the numerator of the following rational numbers. Numerator is what? Minus 6, right? Representation of rational numbers on the number line. In the previous classes, we have learned how to represent integers on the number line. Clearly, every positive integer lies to the right of 0 and every negative integer lies on the left of 0 as shown in this number line, right? Rational numbers can also be represented on the number line in the same way. In order to represent rational numbers on number line, we draw a line and mark a point 0 on it to represent the rational number 0. The positive rational numbers will be represented by points on the line lying to the right of 0, and negative rational numbers will be represented by points on the line lying to the left of 0. We shall explain the procedure with the help of the following examples. Okay. For example, we have to represent 3 by 4 and minus 3 by 4 on the number line. Okay. Now first, this is 0, okay, and 1 and minus 1. Okay. This is 1 by 4, this is 2 by 4, this is 3 by 4, and this is 4 by 4, that is 1. Okay. This is minus 1 by 4, minus 2 by 4, minus 3 by 4, and this is minus 4 by 4, minus 4 by 4, that is minus 1, right? So 3 by 4 is this and minus 3 by 4 is this, right? So what will you do? First, we draw a number line and mark a point 0 on it to represent 0. Number 2, mark unit lengths OA and OA dash to the right and left of O respectively. Then A represents the integer 1 and OA dash represents minus 1. Number 3, divide OA and OA dash into 4 equal parts and take 3 parts of P and P dash respectively. So OP is equals to, that is, this is 3 by 4, and OP dash is equals to, that is this, minus 3 by 4. Okay. Comparison of rational numbers. Before we compare rational numbers, let us consider some facts about comparison of fractions and integers. Number 1, if two fractions have the same denominator, then the fraction with the greater numerator is greater. For example, we have to compare 3 by 5 and 4 by 5. Which one is greater? Of course, 4 by 5 is greater, okay, because here denominators are same, okay. And if two fractions are given with different denominators, then we take the LCM of the denominators. We express each fraction with this LCM as a denominator. Then the fraction with the greater numerator is greater. Okay, for example, you have to compare 5 by 6 and 7 by 9. This time denominator is not same, so we will take the LCM. LCM of 6 and 9 is 18. Now make the denominator 18. 6 into 3 and 5 into 3. 15 by 18. 7 by 9. 9 into 2, 18, 14 by 18. So clearly 15 by 18 is greater than, that is 5 by 6 is greater than 7 by 9, right? So here what will we do? If we have to compare two integers, we know that a positive integer is always greater than a negative integer. Always remember that. And every positive integer is greater than 0. The rules for comparison of natural numbers are similar. They can be stated as follows. Number 1, every positive rational number is greater than every negative rational number. Number 2, every positive rational number is greater than 0. And number 3, every negative rational number is less than 0. So we follow the following procedure for comparing rational numbers. Step 1, express the given rational numbers with positive denominators. Step 2, express the rational numbers as equivalent rational numbers with common denominators. Usually this can be the LCM of the denominators. Step 3, compare the numerators. The rational number with the greater numerator is greater. Example, compare the following rational numbers. Okay, so minus 3 by 5 and 2 by 5. This is positive rational number. So clearly positive rational number is always greater than a negative rational number, right? Order properties of rational numbers. Property 1. For each rational number x, exactly one of the following is true. 1. Either x is greater than 0, either x is equals to 0, or either x is less than 0. Property 2. For any rational number x and y, exactly one of the following is true. Number 1. Either x is greater than y. 2. X is equals to y, or x is less than y. Okay. And property 3. If x, y and z be rational numbers such that x is greater than y is greater than z, then x is greater than z or z. Okay. Now to find a rational number between two rational numbers, we can find as many rational numbers as we want between two given rational numbers. We shall demonstrate this with the help of the following example. Okay. We have to find 5 rational numbers between minus 5 and 2. Okay. So minus 5 we can write as 5 minus 5 by 1. And 2 as 2 by 1. So make the denominator 10. Minus 50 by 10. We'll multiply by 10. 20 by 10. Okay, now you can write any 5 rational number between these two numbers. Okay, so you can write minus 49 by 10, 48 by 10, minus 47 by 10, minus 46 by 10, minus 45 by 10. Okay, there are so many, but we have to find only 5 rational numbers, right? Similarly, you will do this example also. You have to find 10 rational numbers between these two fractional numbers. Okay, rational numbers. Exercise 2.2. Represent the following rational numbers on the number line. 1 by 3. Okay, this is 0, this is 1. We will divide it into 3 parts. This is 1 by 3, this is 2 by 3, and this is 3 by 3, that is 1. So 1 by 3 we have to represent, so this is 1 by 3, right? Things to remember. Number 1, a number of the form p by q where p and q are integers and q is not equals to 0 is called a rational number. 2, all fractions and integers are rational numbers. 3, a rational number p by q is said to be in standard form if q is positive and the q integers p and q have no common divisor other than 1. 4, two rational numbers are said to be equal if they have the same standard form. 5, a rational number p by q is positive if both p and q are positive or both negative. 6, a rational number p by q is negative if one of p and q is negative and the other is positive. 7, p by q is equals to r by s only when p into s is equals to q into r. 8, if there are two rational numbers with a common denominator, then the number having greater numerator is greater. 9, rational number having both numerator and denominator with same sign, either positive or negative, is called positive rational number, and rational number whose either numerator or denominator is negative is called negative rational number. 10, every positive rational number is greater than 0 and every negative rational number is less than 0. 12, for each rational number x, exactly one of the following is true. Number 1, x is greater than 0, x is equals to 0, or x is less than 0. 13, for any two rational numbers x and y, exactly one of the following is true. 1, x is greater than y, 2, x is equals to y, and 3, x is less than y. 14, if x, y and z be rational numbers such that x is greater than y and y is greater than z, then x is greater than z. 15, between any two given rational numbers we can find infinite number of rational numbers. Okay, students, I hope you have understood this chapter. Now you will do practice of this chapter.